All right, so we're gonna take a look at more cofunction examples. Okay, talk about that a little more. So let's look at the first part. So actually, before we do that, let's quickly go over what cofunctions is. So sine of one angle is equal to the cosine of another angle in a right triangle. So let's say we had this. Okay, now obviously the angles in a triangle add up to 180. Now if this is a right angle, then between A and B, they have to add up to 90 degrees. Okay, so let's say the sine of this, sine of A, is equal to BC over AB, because opposite over hypotenuse, and then B cosine of B, so adjacent over hypotenuse, so the cosine of B is equal to BC over AB. So as you guys can see, they have the same ratio, okay? This is a key idea that you guys are going to see. There's going to be a question like this on the regions, I know for sure, so it's important that you guys understand this concept, okay? So let's do some more examples. Let's keep practicing this. So let's look at one. So in each of the following questions, we're just going to solve for x. So here we have the sine of x is equal to the cosine of 65. Now this angle plus this angle is going to equal 90. So x plus 65 is going to equal 90 degrees. So minus 65. So x is going to equal 25. Okay. All right, so same thing for me. This plus all of this is equal to 90. So x plus 30 is equal to 90. So 2x plus 30 is equal to 90. So 2x is equal to 60. So x is going to equal 30. Okay. All right, number 2, solve for theta. Theta, this weird little looking symbol is what we call theta. You guys are going to see it in Trig a lot next year. Theta is just another way to represent an unknown value. Okay, so don't freak out too much. All right, so again, same thing. We're going to solve for that missing value. Same concept, looks a little different. So this plus this is equal to 90. So theta plus 20 is equal to 90. Okay, so we have 2 theta plus 20 is equal to 90. 2 theta is equal to 70. So theta is equal to 35. All right, so same thing here. This plus this is equal to 90. So theta over 3 plus 10 plus theta is equal to 90. Now, theta over 3 is really 1/3 times theta, okay? So this is 1 1/3 times theta if you want to think about it like that, or you can say 4 over 3 theta. That's fine too. Okay, so minus 10. So 4 over 3 theta is equal to 80. Now you guys can either divide by 4 over 3 or you can multiply by the reciprocal. I like to multiply by the reciprocal. So those cancel, so 3 over 4. Okay, so 3 times 80 is 210. 210 divided by 4 is 52.5. Okay, so last one, let's look at C. So again, same thing. So theta plus 3 theta plus 2 theta is equal to 90. So this is 6 theta is equal to 90. So theta is going to equal 15. Okay. All right, so let's look at 3. So in a right triangle, ABC, C is the right angle, and the sine of A is equal to square root of 3 over 2. We want to find the value of each of the following. Okay, so we want to find each of the ratios. Now C is right angle. Okay, now we are given that sine of A is equal to square root of 3 over 2. Now remember, sine is opposite over hypotenuse. Okay, so if we're here, the opposite is this side, so this side is going to be the square root of 3, and the hypotenuse is going to be 2. Okay, now we need that third side because eventually we're going to need that third side. So let's do Pythagorean theorem. So let's just call this x, the other side x, plus the square root of 3 is equal to 2 squared. Okay, so x squared plus those cancel plus 3 is equal to 4 minus 3. So x squared is equal to 1, square root, so x is equal to 1. So this missing side is just 1. Okay, so now we want to find the value of each of the following. So we're just finding a ratio. Okay, that's all we're doing. We're not really solving for anything. We're just going to kind of set up a ratio like they have here in the question. Okay, so let's take a look at A. So A is cosine of A. So remember, cosine is adjacent over hypotenuse. Okay. Now, if we are at angle A, okay, if we're here, this side is my adjacent, and this side is my hypotenuse. So the cosine of angle A is going to equal 1/2. Okay. So tangent of A is opposite over adjacent. Okay. So again, we're at angle A. So my opposite is square root of 3 and my adjacent is 1. So tangent of A is square root of 3 over 1, which is going to equal square root of 3. Okay. All right, so let's look at sine of B. So sine of B, sine is opposite over hypotenuse. So the sine of B, so for here, the opposite is 1 and the hypotenuse is 2. So sine of B is going to equal to 1 over 2. Cosine, so again, cosine is adjacent over hypotenuse. So for here, this is our adjacent, this is our hypotenuse. So square root of 3 over 2. And then C, tangent of B, so tangent is again opposite over adjacent. So for here, this is our opposite, this is our adjacent. So tangent of angle B is equal to 1 over the square root of 3. Okay? And normally I'd like to rationalize the denominator, but well, let's do that quick because I don't like the way it looks with a square root on the bottom. So this is just going to be the square root of 3 over 3. All right, so let's go to the next page. All right, so let's look at 4. So in right triangle ABC, C is the right angle and the tangent of B is the square root of 2 over 2. Okay, so same deal. Except this time we're given that the tangent of B is the square root of 2 over 2. Now tangent, again, is opposite over adjacent. So if we're at angle B, this is my opposite, this is my adjacent. So this side is square root of 2, and this side is just 2. Okay, so now we have to, before we figure out all the rest of these ratios, we have to figure out that third side first. So let's do Pythagorean theorem. Plus 2 squared is equal to C squared. Okay, so those cancel. 2 plus 4 is equal to C squared. So we get 6 is equal to C squared. So square root of 6 is that third side. Okay. All right, so let's look at the cosine of A. Cosine of A is adjacent over hypotenuse, so cosine of A is square root of 2 over square root of 6. Now these can be simplified a little bit. So it's end up going to be like, no, we're just going to leave it. We're not going to complicate things. We're just going to leave it. Can be simplified a little bit, but all right, let's look at 6. Let's look at 6. Let's look at B. Sine of A is opposite over hypotenuse. So if we're at angle A, opposite is 2, and hypotenuse is the square root of 6. Okay, so sine of B, so opposite over hypotenuse. So if we go back and look at B, look at angle B, opposite is square root of 2, and my hypotenuse is the square root of 6. Okay, cosine of B, cosine is adjacent over hypotenuse. So for angle B, adjacent is 2, and square root of 6 is the hypotenuse. Okay. And now we have the tangent of A. So tangent is opposite over adjacent. So my opposite is 2, and my adjacent is square root of 2. Okay. Now we should probably simplify these, but I'm just going to leave them as they are for right now. All right. All right, so let's look at 5, the last one. Now this has nothing to do with cofunctions, but it's a funky SOHCAHTOA problem that's good for you guys to see. So let's take a look. So in the accompanying diagram of triangle NEY, quadrilateral METS is a rectangle, so this is a rectangle. So as you guys can see, I drew in some right angles here, just kind of give us an idea of what triangles are right triangles and kind of what we're looking at. And then angle N, this angle is 52 degrees. Angle Y, this one is 38. SY is 20, and NM is 36. Okay, so we're going to do a few different things. All right, so let's look at A. So first we want to find the length of EY to the nearest integer. Now the length of EY is equal to the length of ET plus the length of TY. Okay, now we cannot just go ahead and figure out what the length of EY is. We kind of have to take a few steps. Okay, so we're going to have to find the length of TY, and that's pretty simple to do. However, ET, there's nothing really to help us to find the length of ET, but since this is a METS is a rectangle, ET, the length of ET and MS are going to be the same length. So if we find the length of MS, we can find the length of ET. Okay. So let's start somewhere. I guess let's start with this one. Okay. I'm going to redraw it, I guess. So here is triangle NSM, 52. This is 36. Okay, so we want to find this one. Okay, so here's my person. So here's my opposite, my adjacent. So I'm going to be using tangent. So tangent, this is part A. So tangent of 52 is equal to, we'll just say O over 36. Okay, so cross multiply. So 36 times tangent of 52 is equal to O. So 36 tangent of 52 is equal to this. So O is equal to 46.0778986. And I know you guys are going to want to round, but not yet. Okay. Now let's find the length of TY. So TY this is my little angle here. Okay, so now what do we want to find? We want to find YT. Okay, so this is my adjacent, and this is my hypotenuse. Okay, so we're using cosine. Cosine of 38 is equal to the adjacent over 20, which is my hypotenuse. Okay. So cross multiply, so 20 times cosine of 38 is equal to the adjacent. All right, so 20 times cosine of 38 is equal to this. So my adjacent is 15.76021507. Okay. So now what I want to do, I need to find the length of EY. So now I can take these two lengths, I'm going to add them together, okay, to get that. So plus 46.07789876. So EY is equal to 61.83811383. So to the nearest integer, it's going to be 62. Okay, so that's the length of EY. All right, so now we want to find the length of EN. Okay, so now EN, kind of a similar idea. EN is equal to the length of EM plus MN. Now, we already actually know the length of MN, which is 36. Okay, so now we need to go ahead and find the length of EM. So similar to ET and MS, EM and ST are congruent, are equal, because that's a rectangle. So we're going to do that same thing. So we're going to find TS, and once we find TS, that's going to give us the length of EM. Okay, so we're going to use this triangle again. This is Y, TS, 38 degrees. Okay, so we want to find TS. So let's call this, okay, so here's my person. So this is my opposite and my hypotenuse. All right, so we're going to be using sine. So we have the sine of 38 is equal to opposite over 20. So 20 times the sine of 38 is equal to the opposite length. So 20 times the sine of 38 is equal to that. Now you guys are going to round, but please do not round just yet. Now we need to add 36 to it because we want to find the length of EN. So we're going to do plus 36. Okay, so the length of EN is going to be equal to 48.31322951. So rounded to the nearest integer, EN is equal to 48. Okay. All right, so for C, using your answers from parts A and B, find the area of this whole triangle. Now, first of all, when they say using your answers from part A and B, that's going to give you permission to use our rounded values. Okay, so we can use these two instead of the decimals. That's the first thing. The second thing is we want to find the area of this whole triangle. So we found EN to be 48, and we found this to be 62. Now it may be hard to tell, but this is actually right triangle. So this is the right angle, right, in this big triangle here. Okay, so this is going to be the base, and this is going to be the height, or that's going to be the base, and that's going to be the height, but we don't need to do any extra work to find the area because we already have the base and the height. Okay, so now the area, as we all know, is 1/2 base times height. So our area is equal to 1/2 48 times 62. So 1/2 times 48 times 62 is our answer. So area is equal to 1488 units.